Hey Nano fan, welcome back. Finally, I found the time to stream again. And hopefully I will be able to do this on a weekly basis now, like I used to do. So, welcome chat. So, hi Andefnal. Oh, of course you're here. Hi, how are you? Is it so incredibly hot for you too? It's incredibly hot in Germany right now. And I work in a co-working space, and there's no air conditioning there, and it's yeah, really tough. Good evening, LFLF. Hey, and again, congratulations to your first contribution, your first pull request. We will have a look at it. Same in Slovakia. I'm cooked. Yeah, yeah, really hard. So. Yeah, let's get started right away. So Madora, hey, how are you? So I started to pick up the RS Nano work again after I had to work for a client of mine, and yeah, that took most of my time. But now I've been busy now working on RS Nano again. So let me switch to the screen. So I think you know the project, or let's just quickly show the website. This is a RS Nano. It's a Rust port of the Nano node, the Nano cryptocurrency node. If you want to know more about Nano, go to nano.org, and rsnano.com is the website for this project. And you can find the source code on GitHub. It's open source. It's on github.com/sympago/rsnanonode. And we are going to work on the networking code today, just like the last streams. And I made a lot of progress there. So yeah, if we have a look at the commits. So this is from today, and I want to continue what I worked on this afternoon. And yeah, as you can see, a lot of networking commits over the last couple of days. And yeah, and let's have a look at what LFLF did. Nearly 40% Rust. That's something I wanted to celebrate as well, because let's see what the script says. We are at 39.4%. So yeah, this is just this whole method is just very rough, but I think it's yeah, it is close to the truth. So 40% Rust, almost 40% Rust. I updated the graph on the website. So here it is. And yeah, I updated this yesterday, and with the changes today, I'm at 39.4, and so this means we will hit the 40% mark this week, maybe next week. I think next week. Yeah, that's cool. And also this graph is a bit pessimistic, because it counts stuff that is not really that important, like the RPC stuff or all of the tests. So I have not ported many of the tests yet, and so that means we from the implementation perspective, we have ported, I think, more than 40% already. Maybe even a lot more. It's hard to tell. And if now asks, how many contributors are there? So not that many. So it's mostly me doing the work, but then there is LFLF, of course. Then there is let's check. We had a couple of pull requests merged. Fiono, of course. Fiono, yeah, not to forget Fiono. He did a lot of stuff. So let's see the close pull requests. Yeah. So yeah, see, Fiono did many things, and now he's busy with his PhD, and maybe he will return. I hope so. And yeah, and also LFLF ported the vote cache. So let's open that one quickly. Vote cache, and this pull request, I finally found the time to merge it. And it was really well done from LFLF. And you used the multi-index container crate for this one, and that turned to work really well. And then I wanted to use it myself for the last thing that I ported with a multi-index container, which is the TCP channels class. And then I couldn't use it because the Rust version is just very limited, and it doesn't offer all of the functionality that the C++ multi-index containers do. And says, I'll find it on GitHub. Yeah. So so LFLF ported the vote cache, and it's merged, and it works like charm. And I worked on the networking part because, like I tell you on every stream, my plan is to get the networking stack on Rust, the full Rust stack on Rust. And for that, I track my progress in this diagram. So let's open that one. And so the last time we were busy with porting the Bootstrap servers. I think we worked on the bulk pull account server, and I finished that, and I finished the other ones that were missing. And I ported the Bootstrap message visitor factory up here. So all of the bootstrapping stuff is in Rust now. And then I went over to the TCP channels site, and I don't even remember what I ported. So there were more boxes gray, and I made the ported ones green. And so almost everything is in Rust now. And the thing I'm working on right now is the TCP channels class, which is a huge one. And I've been working on that one for, I don't know, 2 days, something like that. And I'm, pretty close to finishing it. So that's the plan. I work on the bootstrapping stuff. So let's zoom out a little bit. So the TCP channels class is a very big part, and then another huge one is the network class. And then once we have that, we should be fine with the networking stack, and maybe we find a way to switch to Tokyo async IO Tokyo, because how it works currently we call into the C++ part when we do the async networking, and we get callbacks, and the callbacks return to Rust. And a milestone would be if we would not do that. A milestone would be if we could call Tokyo and have the whole async runtime in Rust. And I have ideas how I could do this gradually. And this will be a difficult task, and I hope we can start that soon. And maybe even on stream, because this would be, I think, interesting to watch. Yeah, so let's go to the TCP channels and have a look at how far we are with the porting of that class. So this is channel TCP. This is it, TCP channels. It's a very big class, and I have not fully grasped what its responsibilities are. It does manage all of the open TCP connections, and it is used also, like, I think when we do we pick random connections to send messages to, and on the Rust side, there's already a lot of code. So let's open that one up. So let's keep the TCP open, and let's open the TCP channels Rust file. So this is the Rust version of the TCP channels, and it is very rough. So I have not cleaned it up at all. You can see this, for example, there's a lot of fields, like a lot of dependencies there, and the construction of the whole thing is gigantic. And yeah, here you can, it's basically the same code as the C++ node has right now. And my plan is to do one thing at a time. So first, just port it as it is, and once I have everything in Rust, then I want to refactor this and make it simpler and more readable and more Rust idiomatic. So how many lines do we have in Rust? Yeah, almost 1,000 lines. So let's see where we have to finish this. I remember today that one thing I wanted to do is I wanted to get rid of the channel TCP observer base class here, because this is something I introduced to decouple the TCP channels from or to break up a circular reference, and right now I moved enough code to Rust that I think we don't need this on the C++ side anymore. So the channel TCP observer is it brings these functions until write drop, I think. So these are the functions from the observer base class, and we call them now from Rust directly, so we don't switch back to the C++ code. We keep it all in Rust, and that's why I think we can remove this channel TCP observer inheritance. And maybe let's find how can we find this out? How can we find out if this is still being used? Channel TCP. Let's find all usages of channel TCP observer. And we have, yeah, the callbacks. I think we can also delete all of these callbacks. So this is the constructor of the channel TCP class. And here we have it. Maybe we don't even need this constructor anymore. This is the only place where it's where we still use it. Let's see, channel TCP constructor. And this other thing here is, yeah, the place we wanted to delete. So let's find for usage the channel TCP of constructor with. So this constructor is the one that takes the observer. Let's search for usages of TCP. Oh my god, that's a lot. Okay, but we only are interested in constructors. It's a shame that I can't search for the usage of the constructor only. That doesn't work, unfortunately. So TCP. So this is the HTTP. This is not relevant. This is all implementation details, like implementations of the methods, and that's not relevant. Except for, okay, I found a usage here that we can't remove yet. Start TCP. Okay, Start TCP creates the channel here. So then I would say we try to bring this to Rust. Start TCP. So this is usually my style of how I work. So I try to find places in the code that I can just bring to Rust without dependencies that are not ported yet. And this is what I'm doing right now. I'm scanning through the code, trying to find good candidates that we could bring to Rust. And start TCP, this is a pretty big thing. So it creates the socket. And what else does it do? It has the observers here. And where does this observers come from? What is that? Oh, this is node observers. This is something else. Node observers is something else. Okay. And we haven't imported node observers yet, so this is already a problem. Maybe we should search for another function we could port, because node observers, that's definitely going to be problematic. Can we just have a quick look at socket? This is the constructor. And here's the node observers. So does this give the node observers to Rust? Okay. Socket TCP. Here is the constructor. Does it give the node observers? Oh, it does. So we have the node observers in Rust. Yeah, okay, then we can port this function. I thought this was not ported yet, but it is. Okay, so then this is already Rust. So all RS Nano namespaces, the RS Nano namespace, all functions in there are from the Rust side. Channel TCP, we can create that one on the Rust side, I think. What else do we have? Now this is the complex part with async connect with callbacks. So porting stuff like that is always difficult. Yeah, but all the rest looks okay. Looks really intimidating. Yeah, this is not so easy. This class, so it was not easy at all. The last couple of days working with this one. Oh, and this calls to other functions on this same class. So we have to go there first. Start TCP, receive node ID. Takes a channel endpoint and a buffer. What does this one do? It has more callbacks. Oh, this looks also really hard. Yeah, sorry chat, I have to find something, and sometimes this takes time. Wow, this is also huge. Wow, huge function. Maybe we find something simpler. I don't want to start with something that is so complex, but maybe we have to. Yeah, I think we have to, because there's nothing left. There's just nothing left that is easy. What is that one? Prepare handshake response. Handshake response create. What does that do? It copies bytes. Yeah, this is a simple thing. Node ID, handshake, payload. Verify handshake response. Okay, yeah, I think we start with these simple ones. And just to get started, so the prepare handshake response is simple. And the verify handshake response is also simple. And then we go to this super complex thing up there. We won't probably reach it in this stream. So this one. Then we will go to start TCP node, receive node ID, because this is just a monster. And we have to use some tricks to port this, because whenever we have callbacks that capture self, this is always hard to do in Rust. But yeah, let's start with the simple ones. So the simple ones, let's start with this one down here. And it's called prepare handshake response. So I go to TCP channels, the FFI part, TCP channels, I part, which is also grown. 500 lines of code. So let's add, let's add something down here. And call it TCP channels. What was the name? Sorry, let's reorganize. The name was prepare handshake response, and it takes prepare handshake response, and it takes the TCP channels handle, and it takes node ID handshake query payload. Node ID handshake query payload. What's the correspondent struct in Rust? Node ID handshake. Node ID handshake query. So this is the query payload, I think. Which is just a cookie. Query payload, node ID handshake query. Okay, so I don't think we have a DTO or anything for it. Node ID handshake query, but it's just a cookie, so we could pass this one as a byte pointer. Just quickly checking that we don't have a DTO or anything else for passing it from C++ to Rust. No, we don't. Okay, but doesn't matter. Doesn't matter. We are going to use a byte pointer for the cookie. So let's say cookie is a byte pointer. And the next thing is bool v2, and it returns a response payload. Okay, so let's add the v2 bool, and it returns a response payload. And the response payload is... Oh, this is more stuff. And we don't have DTOs for this either, do we? No, we don't. Handshake response DTO. Oh, this is a node ID signature v2 salt genesis. Node ID handshake response is node ID signature v2 payload, and v2 payload is salt genesis. We do have a DTO. That's great. So the DTO is this one. So let's use that. Handshake response DTO, and we don't have it anywhere else. So handshake response DTO. So I'm going to add it in here as an out parameter. Sammy D, hello, almost missed the stream. Hi, Sammy. Oh yeah, and by the way, post your Nano addresses. And we will give away 1 Nano or 5 Nanos this stream, like every time. So the result is, hey Colin, welcome. Welcome to this boring networking stream. So I talked with Colin and I, we talked quickly today, and yeah, I said that these streams are maybe a bit boring, because what we do is we just bring the networking code to Rust as it is, and later on I would like to do a refactoring stream where we clean it up or make it more Rust idiomatic. So what I do right now is I'm working with the class TCP channels. I ported most of it already, and now there's just a couple of small functions left and a couple of really complex ones. I like hearing the FFI stuff. Yeah, okay. Let's do this FFI stuff, because this is all like always the same patterns that I use, and they look maybe strange, but yeah, once you get used to it, they are not that hard actually. So I work with the function prepare handshake response from the class TCP channels, and yeah, it takes the cookie, and which is the request payload, and then we return the response payload. And for the response payload we have a DTO already, and this is what was it called? It was called, no, wrong file, this one, handshake response DTO. And this is where we write the results into handshake response DTO. And we need a conversion from the Rust handshake response to this DTO, and I think we have that conversion already in here somewhere. So I have to make it reusable so that we can call the same conversion code in the TCP channels class or FFI part. So this here is the conversion. So let's bring this into an implementation of the from trait. So for those of you who have not worked with Rust so far, so traits are the interfaces in Rust, and we can implement those for any types that we like. And we are going to implement the from trait. So from handshake response. Oh, the lag is horrible again on my PC. So handshake response, node ID handshake response. So we want to convert from the node ID handshake response for our handshake response TTO. So what this does is handshake, oh, it's horribly slow. So let's implement this. So what this does is it's a conversion function that takes the node ID handshake response and it returns a DTO. And we just use the code from down there. And then we can use that and call that in our TCP channels. So this is will return self, which is the DTO, and so node ID is the bytes of the node ID. No, it doesn't work like that. So this is value node ID bytes. Sorry, I'm just really getting confused from the lag here, so I'm not used to that as bytes. And then we have signature, which is, yeah, let's just type it. Value.signature. Come on. Bytes. This is a real productivity killer, like having to wait for code complete. So v2 is value.v2 is sum, like down there. Salt. Yeah, can we just, salt. Salt and Genesis. If let's sum v2. So this is the cool thing about Rust, is that everything is an expression, and I can just add if expressions right into this assignment. Value v2. But let's take a reference because I don't want to take ownership. Then we return v2.salt. And if it's not v2, we return just 0 bytes. What is salt? Salt is 32 bytes. Oop. And LFLF says, thanks for all the work you do, Colin. Yeah, thanks, Colin. Really, like, this is... It's a shame that Nano doesn't get the attention it deserves, because it's just so much better. So Genesis. Let's copy that. Let's copy that and return. Genesis is also 32 bytes. Let's return Genesis here. Genesis. So this should be enough. So now we've implemented the from trait, and now we can call the from function to convert between these two. And this is what I want to do down here now. Instead of doing the assignments manually, I want to say result is come on, response. What is response? What's the type of node ID handshake response? Oh, wait a second. Why does this dereference? Node ID is... What is node ID? Yeah, I have to do the same up here. I have to... Because it returns a reference. And I have to dereference here. So, yeah. Down there, we have to call response.into. And into calls the from trait underneath. So into is also a trait. And when we implement from, into is implemented automatically. So now we have a simple way of converting the node ID handshake response into the DTO. So let's use this in the TCP channels. So down here, oh, this is not imported yet. Handshake response DTO. Handshake response DTO is not in the module, not public in the module, I mean. Node ID, handshake, response DTO. So now it's public in the module, and now we can access it in our FFI function here. And here we call into the real implementation. So handle is the handle for our Rust implementation. So here we call prepare and oh, this is killing me. I have to find a solution. It's so slow. I don't get into the flow. Prepare handshake. If I have to wait after every keystroke. Response. And this will take the cookie, the v2, and this will return the response. What's lagging? Oh, so when I stream, when I have OBS running, everything is just really slow. So I type something and it doesn't show up on the screen for 5 seconds, and I just can't type that way. You'll have to use NVim. Oh, I wanted to, because I was a NeoVim user in the past, and I love NeoVim. I love Vim, and I just I haven't found the energy to configure NeoVim for Rust and C++, because yeah, so Visual Studio Code is cool. I like it, and it works great with Rust and C++ together. And I think it will take quite some time to configure NeoVim so that I can work with in the same way I can work right now in Visual Studio Code. Handle cookie v2 response. So yeah, so this takes so the C++ version takes a query payload. So that's what we need here. Here too, we need a payload, a query payload. Payload. Colin says, I use VS Code, Mac OS, and yeah, it seems to work good. Yeah, so it also works good like when I'm not streaming, but OBS just takes a lot of resources on my system. So the query payload, how is it called in Rust? V2 payload. Node ID handshake. So it's a node ID handshake query. Yeah, there's a big delay, and this is just this is really disturbing because I just don't know what to press next to see what I have pressed already. So the query was the same. Node ID handshake handshake query, and we have to get... No, this has just a cookie anyway, so this has just one field, which is the key. We can just assign that here. Yeah, also the autocomplete doesn't pop up. Now, here it is. Okay, the cookie, we can assign this directly. So we get the cookie as a byte pointer. So let's, as a first step, convert that into a slice, a byte slice. From, come on, raw parts. So the raw part, the data is the cookie, and the length is it also 32 bytes? Is it 32 bytes? Yeah, 32 bytes. And then we can convert that into a 32 byte array with a try into. And try into will always succeed because it is 32 bytes long in the slice. But Rust doesn't know that, so we have to call unwrap here. And the query payload is converted. So now we can pass that into our implementation. Query payload. Ooh. Come on. Query payload. Payload. And this will return a response. Payload. Response payload. And then we have to convert the response payload back into a handshake response DTO. And for that we can use the from trait that we just implemented. So we can say response is so response is response payload into. Okay, so that's the skeleton. So we convert the DTOs into our real data structures that we want to use, and then we convert the result back into the DTOs. So handshake response DTO, let's import that. And now we have to add the prepare handshake response to our TCP channels implementation. So that's this one. No. Here, TCP channels. Here it is. So I'm going to add it just at the bottom. So pubfn prepare handshake response, taking self and the query payload. Which is a reference to node ID handshake query. And v2, which is a bool, and then it returns node ID handshake response. Like that. Okay. Yeah, with this stack, this takes forever. So now we just copy what is in the socket, and we paste this into our Rust implementation. And then let's see what it does. Let's see what it does. Oh, Genesis. So it gets the Genesis hash from the network params. We can do that. So let's Genesis. I think we have the network params in here already. Come on. Oh, this is so frustrating. Let's see why the CPU usage is so bad. Yeah. OBS. And GNOME Shell is also. And OBS again. I thought about buying a capture card because they are cheap. You can get one for 15 euros or something. But then I would need a second computer. So network, where was I? Network params. Is this network params? Yeah. So ledger and ledger Genesis hash. So Genesis. Oh, this is something that I'm going to remove. Colin says, can OBS be configured to use less CPU? Yeah, I switched to so that it would use my graphics card for compression or encoding, and that helped a bit, but still, it takes a lot of CPU. So Genesis, so this is currently, something that I have to change. This is currently using a read-write lock, and the reason was that for some reason this is it's long ago. I don't even know why I introduced a lock there, and I have to remove that because this is just very inconvenient. Because now I have to lock this every time I want to access the Genesis hash. I think, so this is many months ago. I think there were unit tests that would change the configuration after it was created or something, and it was already being used by threads, and Rust doesn't like that. So I had to introduce a lock there. And yeah, so this is something we will have to refactor in the future. So the Genesis block hash, we got that one. And what does it do here? So this is already Rust stuff that I introduced on the C++ side. So it calls node-id handshake response create. So this is basically calling the constructor or creating the handshake response. And I think we can just do the same with saying let result by calling the node-id handshake response constructor or new function if there is some. Maybe there is node-id handshake response. Ooh. And I have to import. Come on. And yeah, so that it has node-id signature and v2. So there is there a constructor? Yeah, there is new v1 and new v2. So we have to know what it is. Is it a v1 or v2? How does where does this one know whether it's a v1 or v2 response? It calls rsn message node-id handshake response create. So let's find that function. rsn message node-id handshake response handshake response create. Here it is. What does it do? Ah, so if Genesis is null, it returns a response v1, and if Genesis has a value, it returns v2. And our Genesis has a value because we just got it from the network config. So we need a v2 response. So new v2. And this takes cookie node ID Genesis. So we don't need that. So cookie node ID Genesis. Cookie is the cookie from the query. So we can say query payload dot cookie. And node ID is from, oh, node ID. Do we have the node ID? Node.node ID. We need the node ID. We don't have the node ID, so yeah, we have to add the node ID to our TCP channels. Struct so self.node ID as a key pair, and Genesis is just block hash. We have that. So this does, yeah, that. So we can delete the C++ code. So we need a node ID in here. So let's do that first. Node ID in the TCP channels. Node ID is, was it the key pair? Come on. And we have to give it to the options too. Yeah, so guys, post your Nano addresses in chat and you can win 1 Nano. Node ID key pair options. Node ID key pair is here. So that means we have to set the key pair in the new function, node ID key pair in the new function. Oh. Node ID options.node ID. Yeah, LFLF. There's a 1 Nano address. Let's copy that. And create a new and def null. So this is LFLF. And we have def null. Yeah. Where was I? So the node ID. So we should have an error here that the node ID is missing. I really like this about Rust. So you cannot forget to set a new field. Sammy D, no address for me. I'm just here to learn. You don't have, but yeah, why not win a Nano? So node ID is where do we get this one from? There's also the DTO, so we have to have the node ID in the DTO. And how can we pass a key pair? Is there a DTO for that? Key pair? Create. Rs and key pair create. What does rs and key pair create return? Key pair create. So this is the function, the FFI function for creating a key pair. Yeah, it just uses two byte pointers for the private key and the public key. So, and if null says we're all here for the text semi, paste your address. You're right, and if null. So that means in the DTO, we have to, let's do it the same way. Let's just add a private key and a public key. Node ID private. I can, yeah, I think the easiest thing is just to use a byte pointer. So that I have to do the least amount of work for that. And the node ID public key also has a byte pointer. All right then. Yeah, good, Sammy. Thanks. So let's take your address too. Sammy. And music stopped. But maybe that's okay. Let's close the music because maybe if my laptop is so busy, maybe it's better to not have music. Okay, go back to... So we have the byte pointers for private and public key. What was that? Oh, a follower. Oh, that's nice to see that this integration works. Thanks for the follow. But where can I see the name? Oh, I can't here. Ah, okay. I have to work on my setup a bit. Okay, so yeah, let's create the key pair from these two values. Nandefna says we are 2 on Twitch. Cool, yeah, great. How many are we on YouTube? Or maybe I can see it here. Maybe let's see. 3. That's cool. Node ID. Oh, now everything is smoother. Was it the music that brought the lag? Max P asks, what's the app that others are viewing from? How do you follow? I'm in YouTube. So I stream on YouTube and on Twitch with this restream tool that just pushes the stream to both platforms. But the followers, I think they are just shown from Twitch. So node ID, where was our value? TCP channel options. So we have the two things here. So we have to say key pair. Let's see, how can we create a key pair from the byte? Oh, still slow, but it's better. Key pair. How can we create the key pair? Oh, we only need the private key bytes. Yeah, because the public key bytes, they can be derived from the private key bytes. So we don't even need to pass the public key bytes. So we call this one here, we just call from private key bytes. Makes it even easier. So let's remove the public key bytes. And let's say key pair from private key bytes. And this takes a byte slice, and the bytes are in value. Node ID. But this is just a byte pointer, so we have to convert this into a slice first. So slice, now it's still slow. From raw parts, come on, from raw parts. And the data is this thing, and the length is how long are the key pairs, are the keys, how many bytes? MaxP says, I got it, thanks. I'll check out Twitch. Thanks for streaming this year. Yeah, sure. This is fun for me. Why can't I jump to the definition now from the... So usually when I don't stream, this works so much more smoothly. So this is really messing everything up. So how long is the key pair? How many bytes is it? 32, right? Yeah, 32 bytes. So we might say this is a 32 byte slice. And so now we convert it from the DTO, and what's missing, the last thing that is missing now is actually setting the node ID private key on the C++ side when we create the TCP channel. So let's do that, and then let's give away the 1 nano. So if you still want to have a chance to win 1 nano, post your nano address in chat. Your last chance. So let's go to the constructor of TCP channels. Channels. Here we are, TCP channels. Here's the constructor. Here's the options. So here we add options. We add the node ID private key bytes. Oh, it's not in here. Node ID. Usually it shows up here already. So that we have that in node ID, I think. Yes. And how can we extract the private key bytes with that one? And how can we get the bytes? Copy bytes too. Number. No. Number is not good. MaxP says, I think it's a fundamental law of nature that things suddenly work less smoothly when someone is watching you. Yeah. MaxP says, please paste your address again. It was lost in the chat. Did I lose an address from MaxP? Oh, yeah, I don't have it. Oh, yeah, I see it. I see it. You don't have to post it again. MaxP. Here we are. Okay. Where was I? Yeah, I was on the C++ side. I wanted to extract the bytes from the private key. And it has copy bytes too. Number returns. No, here it is, bytes. What is that? An array, yeah. Data. Does that work? No member. Oh, this is slow. Okay, so there's no node ID private in the options. Is that right? Here it is, node ID. Yeah, so Visual Studio Code just has to catch up here. Okay. MaxP says, no worries. I think it takes time for my messages to appear. No, I didn't see the nano address. Okay, yeah. So I think we're done here. We're passing the node ID that we converted from the DTO into our Rust version of a key pair. And here on the Rust side, where we have the function node ID handshake response, prepare handshake response, we create the result here. And before we go on with this stuff, let's just give away 1 nano. So for participants, again, let's just use Google. A random number generator. What did I say? 4. Let's just, yeah, 4. So minimum is 1, maximum is 4. Let's generate, and the lucky number is 3. 3, that is Sammy. Congratulations for winning 1 nano. Let's copy your address and let's go to Nalt and unlock the wallet and send. He was just double checking if it's the right, yeah, it's the correct address. 1 nano, and let's go. Oh no, confirm and send. Woohoo, thanks, says Sammy. Congrats, yeah. Okay. So we have to go on here. So this is what the creates and tune piece. Result. I have to look at the original code one more time because this is confusing. Verify. This is the prepare. Okay, because okay, so it's much simpler actually, because the C++ code right here, it calls into the Rust side for creating it, and then it just copies all of that into the C++ response instance. And we don't even have to do that, so that means we're done. So we can just delete all of that, and we can just return the result directly. Like that. Yeah, done. I left good thing you posted your address, yeah. And we have to remove the semicolon here because otherwise we don't return anything. So prepare handshake response. Oh, this is like super simple, like just 2 lines of code. And then let's also port the other one to, there's a warning in here where here v2 is not used. Interesting. Is it the same for C++? Bool v2. Yeah, I think this bool flag doesn't do anything. This v2 flag doesn't do anything. Okay, here's an error still. Undeclared key pair. Port key pair. And let's bring the other function to Rust. So the verify. So, oh no, one thing is still missing. We have to call our new Rust function here. So that is rs nano is the namespace, rsn TCP channels, prepare handshake response. There it is. Handle. We have to pass the cookie from the query payload, which is called query. So query.cookie. Come on. Loading cookie. Dot bytes data. We have to pass the v2, even though it's not being used, and we have to, yeah, for the response, the handshake response DTO. So let's create that one. Handshake response DTO response. So let's pass that in. Response. And the only thing we have to do now here is we have to convert the response DTO back into Node ID handshake response payload. And maybe we can reuse this code down here, because this does copy here, but does it copy result? Yeah, let's just rename it to result, because I think then it would just work immediately. Yeah. And this one has to be renamed to result. Okay. And the file says there's just the if result v2. Was there an if on the Rust side? Where can you tell me where you saw this if? Oh, this returns a result, but this will always succeed. So let's just unwrap it. C++. I want to have a quick look at the original Nano node code, because I already changed that one, so I want to see how it works on the real node or the original node. I mean, let's go there. Let's go to tcp.cpp. And let's search for prepare. Oh, prepare handshake response. What is this? Oh. Oh, this is, I moved it. Network. This is network. Okay. I moved this function from network to here, probably to remove a circular cyclic dependency. So then let's, or I think I can also search for prepare handshake. No matches found. What was the name? Prepare handshake response. Okay, then we are, let's search it here. Prepare handshake response. Here it is. On line number 804. Oh. Sorry, where is it? 804. Oh yeah, here is the if v2. Yeah, maybe then this has to do with my refactoring, because I think maybe v1 shakes are not supported anymore. And this is a good question now. Response payload, prepare handshake response. Let's search it again. Here it is, here it is. Where is it called? Two places. Here and here. Handshake is v2. Hmm. So, okay, I don't want to spend too much time researching this. I want to change the code so that it actually considers what this v2 parameter does. So I don't want to just say v2. I want to say if v2, then we return, oh, it's so slow again. And if it's not v2, we return the old one. And then that means we only need the genesis in the v2. Ooh, what's that? And here we say new v1, and this does not need the genesis block, genesis hash. So now it's, I'm confused now why this code was not there anymore. Because yeah, but this is obvious. This is more correct, obviously. Okay. Oh, I need to have a bit of water. Oh, it's so late. Let's do another giveaway. Let's do another one. So 4 participants. Ah, the nanomag, yeah, it really helps when it's hot like that. But no beer. No beer. Let's oh, Sindor, wait for me. Yeah, I will. Just post your nano address. So this was prepare handshake response. And the next thing I would like to port is this one, the verify handshake response. And this takes the response payload and an endpoint and returns a bool. So, oh yeah, here you are, Sindor. Let's copy your address. Copy. Okay. That action hero, hi. I wish I could rain Nano here on Twitch. Oh, that would be cool. Maybe in the future, if I have more time and I'm done with porting it to Rust, we could spend time with some fun projects like writing a bot for that. So max is now 5. And let's go. So winner number 4. So that's Max P. Congrats. Copy your address. And let's send you 1 nano. Is that the right one? 3TR? No, that was not the right one. Copy. Yeah, now it is. 1 nano, and let's go. Okay, so let's do the next thing, the prepare handshake response. So let's create an FFI function. Here's the FFI part. let's put that one here. Let's create an FFI function for it. Where was the other one? Channels. Let's search prepare. Yeah. Let's put it below that one. And so this is the C++ definition. So we want to the MaxP says, thank you. And if not, says, as someone many times said, Nano is the light. Wenderson, where is Wenderson? So if you want to try out porting stuff from Nano to Rust, my advice would be just find a very simple function. A very simple function in C++ that doesn't use anything special. And then, yeah, just write the FFI function like we do here. And yeah, and just pass all the arguments either as pointers or as DTOs. And prepare handshake. Prepare handshake? I copied the wrong thing. I wanted to copy verify this one. Yeah. So this is not prepare handshake response. This is verify handshake response, and it returns a bool. It takes the response, which is handshake response DTO. It takes endpoint, and for endpoints we have a DTO as well. Endpoint is endpoint DTO. Like that. Andifnal says nothing special, just CPP and Rust. Yeah. Yeah, it's oh, what did I do here? Not like that. Yeah, this FFI thing is tricky to not shoot yourself in the foot. Okay. So this is the FFI function, and we do the same thing basically that we did up here. We have to convert, oh no, now we have to convert the handshake response DTO from the DTO to our actual thing. So I want to do this with the from trade again. So let's implement the from trade so that we can convert from handshake response DTO. Come on, DTO. For handshake response. Oh, this is so horribly wrong, slow. Can't work like that. Handshake node ID. What was it? Node ID handshake response. Node ID handshake response. But we want to convert from references or from borrows, because this is what we get in our FFI functions. And yeah, so here we say if value so if it is a v2, we return node ID handshake response new v2. Node ID, come on, handshake response new v2, and it takes the cookie node ID genesis. Cookie value is Cookie? What is cookie? Cookie? Genesis? Salt? There's no cookie in the DTO. Okay. Okay. No. This does stuff. We don't want to do that. We don't want to sign stuff. So we want to actually create it like we do here. Account signature and payload. So, but we can do that. So we just don't use the new constructor. We do it like that. So we say node ID is public key. Is a public key from, can I convert it from that? Is there conversion from 32 from a 32 byte array? Oh, here, from bytes. What does from bytes do? What does it take? Okay, just the bytes. From bytes is value dot node ID. Signature is signature. Does signature also have a from bytes? Yeah. Value dot signature. And v2. Yeah, so here we don't even, so we can delete this if statement. We can include it right in here. We can say, so this is an option, I think, option v2 payload. So we can say if value.v2, we return the payload, else we say none. And the payload is payload. What does it have? Genesis and salt. Genesis is value dot block hash from bytes. I have to find a solution for my computer to be faster. From bytes value Genesis and salt is just value dot salt. Oh, and this has to be sum. Okay, that's it. So now we have the conversion function. The conversion function from the DTO into our actual node ID handshake response. And we can use this. Oh, what's wrong here? Block hash. Oh, I have to convert the block hash into bytes. So now we can use this in here, in our FFI function. So let's convert the response into our domain. Let's say our domain model response is node ID handshake response from response. And this is mutable. It doesn't have to be mutable. Let's remove the mutable. And let's also convert our endpoint into a socket address. from endpoint. And then we can just return whatever our actual function returns. So we say handle at 0. I have to say out, it's too slow. Verify handshake response. And it gets the response and it gets the endpoint. And it returns a bool. Yeah. Oh, okay, so like that. So it returns a bool. Verify handshake response with that. So let's go here to where we had our prepare. And let's add the verify handshake response. And verify handshake response. It also takes self. And it returns a bool. And oh no, we have to define the types here. So response is a reference to node-ID handshake response, and endpoint is a reference to socket address. Okay. So now what we have to do is to copy the implementation of this function from the C++ side. This one. And copy it into here. And yeah, let's port it line by line. So if response node ID is the same as our node ID, then we do return false and we do increment stat here. So we can do that with self.stats.inc. And this is stat type handshake. Stat type handshake, come on. And the detail type is invalid node ID. Type invalid node ID. Oh, is this slower node? Is this the right one? Was it invalid node ID or invalid node ID handshake? No, it was invalid node ID. Yeah, invalid node ID. And direction is there's nothing given, so I think default is always in or out. Let's see, ink. Where is the ink? In. So it's in. Yeah, makes sense. So direction in. Okay. So next one. Prevent mismatched genesis. So what does that one say? If response v2 and response v2 genesis. Ah, okay, this is an option. Sorry, so we have to So if let some v2 response v2. And now let's move the other condition inside this if. If, no, we don't need parentheses. So this is the other condition, if response. So this is just v2. If v2.genesis is not the same genesis hash as ours, so it's that we can access ours in here again with self network ledger genesis. Come on, read log. Hash. So if the genesis hashes don't match, then we also, let's copy that here. So we fail with, or we say stats increase handshake, detail type is invalid genesis. So if you're wondering what this stats stuff is, this is counters that we can use to debug or analyze our nodes. These are just simple counters that we can query from RPC. Invalid, what was it? Genesis. Come on, invalid genesis. Okay. Okay, what's wrong here? What's wrong here? Oh, nothing. Okay. Oh, there's something wrong here. If maybe missing an else clause. By the way, I wouldn't want to capture that. I don't see a missing else clause. Oh, yeah, maybe because the bool up here. Yeah, because we don't return a bool. Okay, so let's go on. Cookies, syn cookies. Syn cookies. Do we have that yet? Self dot. Do we have it? No. So we have to pass the syn cookies into the TCP channels. As arc. And as you can see here, there are a lot of arcs. And this is just temporary because this makes porting it from C++ to Rust really easy. And this is not like how you should structure Rust programs. And we will refactor that as soon as we have everything ported. So syn cookies in the TCP channels, we have to add it into the options. And we have to add it into the DTO. Oh, time is flying. I wanted to stop streaming in 20 minutes. So, and we only gave away 2 nanos. Let's just give away more nanos now. So if you want to take part, just post your nano address in chat. I give you 1 more minute if you to post your nano address in chat. And yeah, And while I wait, let's just add the sync cookies to the options DTO. Where's the options DTO? Here. So here we need the sync cookies as I think there's just a sync cookies handle. Yeah. And with this, we can edit or convert the sync cookies handle down there into sync cookies arc. Sync cookies. So this is a raw pointer, so we have to dereference it. And then we can access the arc. Like that. And oh, it complains. Why does it complain? Private. Oh, I didn't make sync cookies public. Oh, I did make it public. So maybe it's just Visual Studio Code. It's being slow again. Oh no, the field is private. The field of sync cookies is private. Let's make it public. Okay. And so let's just wonderful. There are 4 people on Twitch. Wow, hey, that's cool. Welcome to all the new people. Yeah, we are working on a Rust version of the Nano node, the Nano cryptocurrency. And what I do is I port the original code base line by line, function by function, class by class, and while I keep the node running. So this is not like a rewrite where we don't know where it leads to. We actually have a running node here, and I carefully bring the code over line by line. Now I forgot what I wanted to do. Oh yeah, the sync cookies. I have to set the sync cookies on the C++ side. Okay, that is in the constructor, and we just have to find it. With this huge font size, it's really hard to find stuff. Where is here? It was. Was it here? No, it was .tcp. Here, no, keep alive. Where is the? Here it is. Here it is. So here we have to set the sync cookies. So options. Sync cookies is. Where can we get it from? Is it in the node? Is it in the network? I think it's in the network. Network. Sync cookies. Yeah, here it is. And it has a handle. Cinder says bye. Bye, Cinder. See you next time. Okay. Yeah, that's it. So let's send away the last nanos. MaxP says, well, I didn't really realize that. What do you mean? The node is running the code that you are writing as soon as you save it? The node is running the code that you write as soon as you save it. So, oh no, it's not like that. But with running, I mean, the whole system would just run like you could just start the node, and it's not like that I do live updates to an actual running node, but I just I'm just careful to not break anything. You know, so we could just take this version now when I check it into push it to GitHub, and we could compile it, and it would probably run. Nano node with hot reload. That would be difficult to accomplish, and I don't think it's worth it. Oh, there's some flea. Yeah, but the node, it works. So I do have beta nodes running, and it works actually pretty well. A little bit slower than the C++ node because of all of this FFI stuff, but it's not too much slower. Okay, handle. So we added the syn cookie handle. And oh no, I wanted to give away nanos. That's what I wanted to do. Let's take a random number. Are we still 5? I think so. Yeah. And let's generate a random number. 5. 5, that means winner is 0 or all is left. Doesn't matter, he still gets it. Copy. MaxP says, cool. So it can run as a hybrid between CPP and Rust. Yeah, I would imagine that you need to first convert every file to Rust. No, so I do this like in these small steps because the code base is huge, and if I would try to port everything at once, I would get lost, and I would certainly introduce many bugs. And the way I work is just moving small parts of code from C++ to Rust, and we have the unit tests and other tests that I can run to verify that the system still works. And yeah, by working in these small steps, I don't get myself into trouble. And I can track the progress like I do here on my website, where I count the lines of C++ and the lines of Rust and compare them. And so that makes it a nice stress-free project. Just minimizing the unknowns. And the goal is, of course, to have everything in Rust. Colin says, bit by bit is a good strategy. Yeah. So also I heard from this strategy years ago from the author of Domain-Driven Design. Does anybody know his name? Do you know the big blue book, Domain-Driven Design? It was a real hit years ago. I think it's still very relevant. And I watched a talk from him, like, I don't know, many years ago. And it was about migration or the big rewrites and how they fail. And haven't read it yet. It's an old book, but it's a really good read. And so this book is basically about how we can write our code so that it matches the problem domain and that we don't have the language barrier when we talk about our code and when we talk with the customers. So that we just use the same language. By the way, Gustav, how do you catch up with the CPP code base changes? So I watch the official repo, and whenever there are new commits, I merge them one by one. And nowadays, that means I get many merge conflicts because I have changed so much. But yeah, that's just something then that I have to dig through. But it works. It has worked out fine until now. So and he gave a talk about how his experience with big rewrites and how they fail, and that let's say they have a legacy system with problems and they want to do a big rewrite, and then they put together a tiger team, like the best of their programmers, to rewrite the thing. But the old system doesn't stand still. It still gets developed because the customers, they need stuff done, or they need new features or bug fixes. And then you have this race of the old system and the new system. And then a decade later, the new system is finished, but it's legacy again. and then you could start the next rewrite. Colin says, my experience is the same. Yeah, doing a rewrite in a huge chunk will almost 100% fail. I agree. Yeah, yeah. Yeah, so I prefer to minimize the risk, and that's what I'm doing here, just small steps. I can verify that it works after each step, and that's just minimizes the risk, and I find problems early. And also, like, there's so much knowledge in the Nano code. So the Nano network has been running for, when was it launched, Colin? 2014? I don't know. When did you start the network? 2014, 2012? And there's so many attacks and so many things were going on, and all of that was mitigated in the code. So there's so much knowledge in the code and so much testing in the code, and it would be insane to throw that away. So I want to use this. I want to use all of the knowledge in the code. October 2015. Okay, yeah. October 2015. Learned something new. Yeah, and now, yeah, so that's roughly 8 years. Roughly 8 years, and yeah, so I want to use all of that knowledge in that I can get. And if not, so who remembers BitGrail? I don't, because I stumbled upon Nano in 2019 or 18. I don't remember. 18 or 19. And it was one of Patrick's videos where he compared Nano to Lightning, and that got me hooked. Max Peace has great philosophy. Yeah, so we can learn from the mistakes others make. So I just saw or the points that Eric Evans. Now I remember the name. Eric Evans is the guy who wrote Domain-Driven Design, and he's a very smart man, and I take his word for granted when it comes to that. Yeah, BitGrail. I learned about Nano in 2018 or 19 from one of Patrick's videos, and then I joined the Discord, and I was a passive reader for, I don't know, 2 years, and then I started this RS Nano project, and I just wanted to see if it's possible. Or no, actually, I just had the idea in my mind for maybe a year, but I was very busy, and I always wanted to do it. And then one day I said, oh, I just want to port like one class just to see if I could do it. And then it was so much fun, and that I couldn't stop doing that. And now it's, I don't know, 2 years now, and for 40% ported. And I thought I would be faster. I thought it would be done in a year or two. Yes, so yeah, I think I call it a day here. Didn't really get much work done. I have to solve this slow computer thing because this is so annoying that I can't type fast, and I can't get the code completion fast. I feel like I have some like I'm chained to or have a metal ball on my foot and I can't walk fast. Yeah, maybe a capture card. Okay, so just I give away one more Nano, and then I call this a day. So let's create one more random number. Click 2. So congratulations. Undef null. So this is your address. A9. Let's send you one Nano. Okay. Chat, it was fun again. I hope you had fun too. And so my plan is to, get this networking code to Rust and then to switch to Tokyo, the async runtime of Rust. And I'm really excited about that. And I hope I can stream that, because that is a lot more interesting than just porting that code. Max P says, woohoo, congrats, have a good night. Thanks for streaming your process. Yeah, sure. I enjoy that very much. The Twitch lags, yeah. And maybe, just maybe, I'm not sure if this will work, but maybe I will stream next week during the day, because my girlfriend and the kids are gone for a couple of days, and maybe I will stream for a couple of hours then, maybe next Tuesday, but it's not sure yet. So I will announce that on Twitter, or it's do you call it X now? I will announce it on X and on Discord. So have a good night, everyone. And LFLF says, awesome stream. Great to see you get back to Rust Dev. Yeah. I'm going to stream weekly again. So there's going to be a stream next Tuesday. So the question is just, maybe it's just a short stream like this, or maybe I'm going to stream for, like, I don't know, 5 hours or something. Okay, so good night, guys. Have a good one. Bye.